Hello everyone. So today I'm gonna show you guys this GUI that I built. Basically it's a GUI that solves for the deflection of beams, and it only solves for simply supported or cantilever beams that have either concentrated loading or distributed loading. So basically how I set up this GUI is the user comes in and puts in all the properties right here in the create beam section. So this whole square here, you come in and you create your beam by listing all of its properties, the type of loading, the location of the loads, the value of the load, and then specifying whether it's a simply supported beam down here or if it's a cantilever beam. And once we go through all that, then we come down here and discretize the beam. And basically what this is this is setting up the solver. So for the simply supported beam, we're using finite differencing, and for the cantilever beam, we're using a mixture of Hume's method and Euler's method. Since the cantilever problem, it's an initial value problem, and the simply supported is a boundary value problem, so that's why we chose those two different solvers. And again, when we discretize it, we're basically setting up the number of iterations we're going to do for each solution. So let's just go ahead and build something so you guys can see how it works. So I'm going to assume that there's no axial force here. Another thing that this program assumes is that the user is inputting all of its parameters in the appropriate units. So either you're using SI units or US English units. So I'm going to assume that this is all in SI units. So let me finish filling this in. The moment of inertia 5 point. Beam length, I'm just gonna guess something 6, and type of loading, let's make it a point load in the center of the beam, simply supported beam with 1000 newtons. Let's just choose a number of nodes of 100, or yeah, and then create the beam once we're done. And right away it pops up right here in the first graph and it displays the beam we're trying to solve. So if we want to use a cantilever beam, and it just displays that. We want to use a distributed loading from 0 to, I don't know, 4, update it, and then it shows that, or concentrated, or simply supported with distributed loading. It just displays that, and all these three other graphs don't show anything until we press solve. So I just press solve, and right here the first thing that pops up is a warning, and this warning is basically telling us whether the deflection of the beam met the allowable deflection, which the allowable deflection in this case we set it as the length divided by 360. So if the deflection is less than the length divided by 360, then the allowable deflection is less than the maximum and it's allowable. So there we go. If we exit that, this is the deflection, and right here we have a bending and shear diagram. So if we were to solve the same thing before a point load, update that and solve this. So same thing, this thing shows us whether the deflection is satisfiable or not, and then a new bending moment and shear force diagram. So there it is, a GUI built in MATLAB that currently only solves simply supported and cantilever beams for concentrated or distributed loading. Thanks for watching.